Hi, we're going to go through the process of replacing the nozzle on this CR-10S, and also we're going to set up the offset. The main idea is to go from the old used nozzle to the new one and get the printer ready to go. All right? So the first step is to heat up the nozzle. In order to do that, it's already hot, but I'm going to show you the steps. You press the button, you're going to prepare, then you go into the preheat PLA, because we are using PLA, and then preheat just the end, right? That's going to set up the temperature to 200. You wait until it hits that temperature, and then we're ready to go. So these are the tools that you're going to get when you get the printer, and they're okay for casual type of work when you do this not that often. In my case, I have to be giving maintenance to many printers, so I have my set of tools that I use for this, so they're going to be looking a little different. Anyway, so the first step is going to be to remove the case on the assembly as well as the ABL. We do this, 2 screws, right? And I always have a little cup where I put them so I don't lose them, right? This is one of it. This is the other. That takes care of these 2 pieces. And many times you need to cut this zip tie so you can have a little more freedom of movement. That frees up the heat block and all that stuff. Okay. You remove this protective sleeve very carefully with the pliers. Remember, it's very hot. This block is very hot, so everything you do have to be very careful. Usually you can take the nozzle out with this one, but I'm going to use a faster one. I use this faster one. With this one I can take the nozzle out. You can see the nozzle now, it's here. The next step is going to be to pull out the bowden. Sometimes with the pneumatic coupler is loose enough, you can just pull out the bowden. If it doesn't come out, just take off the magnetic coupler, and then you can take off the whole bowden. Just make sure. You're going to see that sometimes the bowden's a little dirty on the top. One of the things I do with this bowden cutter that usually comes when you buy new bowden, cut the tip of it, right? Just cut the tip of it and make sure there's no material left inside the bowden. The next step is going to be to clean up the heat break, which is the part in the center where the bowden goes. This is the heat break. This goes inside this piece, and this is what we're going to clean up on the inside. One that we do, we take an old bowden or the one that we have and just run it through to make sure we can take off all the little pieces of plastic that we have from both sides. And then with a little alcohol, this little jar has alcohol on it. You take the alcohol and then clean with a Q-tip the heat break. Once you make sure it's clean, then you put the nozzle back in. You can wait for the block to heat up. You can very carefully give it a couple of rounds so it goes in. And then go all the way to the end of it. Once it gets to the end, go back 1.5 turns. So it's going to go down 1.5 turns. We put back the pneumatic coupler tighten it up a little, not much, just a little, and then you can put back the bowden. Once it's all the way down, make sure it hits bottom, and then you can tighten up the nozzle. What that guarantees is that the nozzle and the heat break are flush, and the bowden hits the nozzle, right? So we make sure that the nozzle and the bowden are flush, and that's why we do the 1.5 turn, put the bowden, and then pull it up. One thing I always like to do before putting everything back together, make sure that these 4 parts are tight. Sometimes these guys get a little untight. These 4 screws here, and this little guy here. That ensures that everything is tight and you don't have loose pieces. Once that is done, you can very carefully put back the sleeve in place. Remember, the block is very hot, and we put back the assembly with the EZAbl. Here goes one. Never tighten too much, just enough to feel that it's tight. But if you tighten too much, then you may break things. So this little part goes here. Right? We're almost ready to go. One last step. Put a little zip tie in here. And cut it. And now we're ready for the next step, which is going to be to align the offset of the nozzle with the bed. So now the nozzle and the bed are hot. The next thing we're going to do, we're going to home the printer so we can start the process, right? So while this is homing, the next thing that we're going to have to do is to reset the EEPROM of the printer control. So you can do this 2 ways. One is, and I'm going to show this one. The other one is you can go to all your terminal and do a G code M502 and then M500, right? Oh, but the easiest one is just go to control. Here, you go to control, reset EEPROM, reset the EEPROM. That sets up all the original values for it, right? So once we have the printer ready to be leveled, the next step is that I'm gonna very slowly, with the prepare move axis, right? I'm gonna moving the nozzle down very carefully. So I'm moving 1 millimeter at a time until I feel that it's getting close, and then I switch to 0.1 millimeter here on the screen, and now I'm going 1/10 of a millimeter until I see that there's no gap between the nozzle and the bed. So the next part is to make sure that the distance between the EZAbl and the bed is 2 millimeter, and this happens to be a great gauge that tells us if we have 2 millimeters, right? So here you can see that the EZAbl is too high, right? So we're gonna lower it until it hits the little wrench here. So it gives us about 2 millimeters. We tighten it up, right? And it's ready to calibrate. Once we know that it's touching and the EZAbl is 2 millimeters, we bring up We bring up the nozzle 2 millimeters. Right, so it was 0.4, now 1.6, that's the 2 millimeters. So now the nozzle is 2 millimeters high on the bed. With a little screwdriver, you take the EZAbl and turn it until it turns from green to red. So once it is 2 millimeters high, then you turn the EZAbl until it turns red very carefully, and that means that the EZAbl is gonna detect when the nozzle is 2 millimeters over the bed, or approximately. Now comes the next part, which is setting up the offset. Setting up the offset is gonna be, we're gonna give the printer instructions to go down a certain amount of distance before starting printing, so it doesn't stay that way. So we go and do again, prepare and auto home, right? That's gonna auto home to the calibration that we did for the EZAbl. Now we're gonna start moving the axis down to see what our offset is, right? So 1 millimeter, the nozzle stops at plus 5 millimeters, right? So you can see the distance now on the nozzle. As we bring it down, it's gonna come down. Here's our 0, which is about 2 millimeters. We'll bring it down a little more, and now I'm gonna switch to the 1/10 of a millimeter, and I'm gonna keep bringing it down until I feel the pressure on this piece of paper, right? I can see the pressure. That means that the nozzle is enough down, and here we have that it had pressure in minus 1.6, right? So what I'm gonna do, first I'm gonna bring the nozzle back up, because otherwise it's gonna do weird things, and I'm gonna go here to the control, motion, offset, and this is where I put the minus 1.6 that we just saw in there, right? At this point I go back into store settings, and we're all set. How did I do the store settings? Control, store settings, right? So now our offset is set, and we're ready, almost ready to print. One more thing. The way that your printer is set up is that we eliminated the springs that you had here, so all the distance here is fixed. What we can have sometimes is that the gantry is not perfectly aligned. So what we do is we make sure that the gantry is aligned. We take this caliper, right? Zero it in, and we measure the distance, which in this case is 55.58. And let's do it on the other side of the gantry. Here we have 54.59, right? That means that the gantry is a little tilted to the top. So what I'm gonna do is, since it's engaged, the stepper is engaged, I'm gonna bring it down a little, and I'm gonna measure again. So my gantry again is gonna be 54.77, 53.57. I'm gonna bring it up a little. So at this point we have 55.85 here and 55.72 here. So at this point we're confident that the gantry is leveled enough that the EZAbl is going to pick up the difference and create the level map without a lot of trouble, right? I'm going now to put a little filament on the printer, and we're going to start a print to see how it looks, right? So I'm putting a little filament in. Instead of using the instructions of the printer, I usually straighten out the tip and push it until I see a little coming out. Now, The next step is I'm going to, through the Octoprint, which you should have, set up a print of the test print that I have for this printer. When you got this printer, there's a Raspberry that comes with it with Octoprint. The instructions on how to set it up is there. And we have Octoprint here ready to go. It comes with this test piece. You may have the other ones. So we're going to set up this little dog to print. And one of the things that may happen at the beginning is that our offset may not be perfect. So we're going to go and do the baby steps. Okay? So now it's doing the leveling, it's mapping the table. Right? It's going to map 5 rows of 5 points each. And it's going to use that to make sure that all the print is leveled. Right? Once it starts printing, we're going to go through the baby steps adjustment, which is if we see that the line that is printed is too high or is too low, we can adjust a little. And the way that we adjust is by hitting the bottom 2 times. It's going to take us in the baby step mode. You're going to see that once it starts printing. In order to adjust, I'm going to hit 2 times the button here, and it takes me into the baby step mode. As you can see now, the layer is a little too high, so I'm going to bring it down. I'm going to bring it down a little on my side. I'm going to go to -1725, and we're going to look to see if it improves the layer. And it looks a little better now. Come here, click another time, go back to control, and store this latest setting that I have. Wait about an hour or so for the piece to print, but once this is done and the printer is working, you can say that you're done with the replacement of the nozzle and resetting of your offset.